Le Chatelier's principle has to do with equilibrium reactions, and it states, when you disturb an equilibrium reaction, the system will respond to counteract or undo or reverse the change. Here is an equilibrium reaction for us to consider. Hydrochloric acid reacting with oxygen in equilibrium with water, chlorine and energy. This reaction can also be referred to as an exothermic reaction because the energy is a product, or it could have been written that the heat of reaction was a negative number. Both of those statements imply that energy is to be written as a product. Now, it is useful to consider disturbances to equilibrium reactions under the following headings. You ask yourself, what's the change? The response will be always the opposite to the change. That's what Le Chatelier's principle is implying. And how this will happen is asking you whether you will favour reactions to the left or right to get that response to occur. And I'm going to consider 3 disturbances. The first one involves changing the temperature. If my disturbance is to increase the temperature, my response will be the opposite, to get the temperature to drop down again. And this can be achieved by going to the left, because when I say I'm going to the left this way, I'm using up the things on the right to make the things on the left. And one of those things I'm using up is the one I want to, which is the energy. My next disturbance is changing the concentration of the reactant hydrochloric acid, in this case increasing its concentration. The response will be the opposite, to get the hydrochloric acid concentration to drop down again, and this can be achieved by going to the right, because going to the right will use up some of that extra hydrochloric acid added. My final change involves pressure, and volume would be treated the same way. And in this case, we need to consider the overall numbers of molecules on both sides of the equation. Here I have 5 gaseous molecules on the left in equilibrium with 4 gaseous molecules on the right. So changing pressure or volume in this particular example will have an effect. If you did that tally overall count both sides and it came out to be the same, then changing pressure or volume would have no effect in that particular example. But in this one it will. So if my disturbance is to get the pressure to go up, now in that case we would imagine that we're in a container with a movable wall. And to get the pressure to go up, I would have just got the volume to go down, because I would put all my gaseous molecules into a smaller space and that would achieve that pressure going up. My response would be to get the pressure to go down again. And I will achieve that by going this way, because I am favouring the side that has less gas molecules. Because I know if I have less gas molecules in that confined space, I will achieve what I want, which is to get the pressure to go down again. So to recap, Le Chatelier's principle states that if you disturb an equilibrium, the system will respond to counteract or undo the change.